This is AB Calculus homework help over finding where a function is increasing and decreasing for a f prime of x function. So this exercise set today was going to do our problems 2 through 7. I'm going to show here. And this is the first one here, problem 2. And I've agreed to do on video problems 3 and 4. And so it's the same situation, f prime of x. And I'm going to tell you what we plan to discover from this f prime of x. We tend to discover where f of x is increasing and decreasing. We're going to find relative extrema of f of x. What else? Points of inflection of f of x. F of x, intervals of concavity. So that would be concave up and concave down, intervals where the function f is concave up and concave down. We'll find the possible also sketch, I'll say sketch possible graph of f of x. And finally, give possible algebraic equation or function for f of x. Okay, the first thing we're going to do is I'm going to rewrite f prime of x is equal to 18x squared plus 36x. And if we set f prime of x equals 0, we're going to be able to find critical numbers, and a common factor between these two terms is going to be 18x. And 18x times what equals 18x squared? Well, it's going to be x. And 18x times what equals 36x is going to be plus 2. And so our critical numbers are going to be x equals 0 and also x equals -2. And next, for analysis purposes, we're going to construct a number line with the critical numbers on this number line of -2 and 0. And then up above, I'm going to put f prime, and below the line, I'm going to put f. And then we're going to analyze this function here, this equation, 18x times x plus 2. And so to the left of -2, we're going to have a negative times a negative, which will be positive. So we know our function is increasing through neg infinity, x equals -2. Then between -2 and 0, say -1, we would have a negative times a positive or a negative. So we're going to be decreasing between -2 and 0. And then if we have greater than 0, we're going to have positive times positive. So that's what our number line looks like. And so we're going to say f of x is increasing on negative infinity to -2, and also between 0 and infinity. And why is that? It's going to be because f prime of x is greater than 0. Okay, next, we're decreasing. F of x is decreasing on our interval that remains, -2 to 0, because f prime of x is less than 0. Okay, now the next thing we're going to do is take the second derivative of this, and we already have the first derivative, so f double prime of x is going to be the first derivative of 18x squared plus 36x. So for that, we're going to get 36x and then we're going to have plus 36. And then if we set that equal to 0, 0 is going to be equal to 36 times x plus 1. So it means for concavity, we have a critical number of x equals -1. And I'm going to draw another number line down here. And on this number line, I'm going to put -1 in the middle and f double prime above, f below. And then to the left of -1, we could have like -2. We'd have a negative. So we're going to be concave down over this interval. And then to the right of -1, say 0, we would have a positive, or concave up. So we have the analysis piece right here, down here, and I'm going to write my, we'll say we have a point of inflection at x equals -1, because f double prime of x changes from negative to positive. Okay, concavity, we will say, let me write this in, f of x, make this, has point of inflection, okay? F of x is concave down on the interval -infinity to -1, because, let me go ahead and write that out better, -infinity, it's still not looking very good, -infinity to -1, because f double prime of x is less than 0. Okay, f of x is concave up on -1, greater -1, less infinity. Why? Because f double prime of x is greater than 0. Okay, so that comprehends all these four things here. Next, what I'm going to do is graph. Before I graph, I'm going to draw this little circle that I've brought up in my classes that seems to be quite helpful in what kind of piece to put in what place. If you have a function like this up quadrant on the upper right, where your function is decreasing, but it's like a down curve, that's going to be a decreasing function that is concave down. To the left, you are increasing, but you still are concave down, like a frowny face. Down here in the lower left, we have decreasing, and you are concave up. In the lower right, you have increasing, and you are concave up. So those are the signs of, on the top, F prime, and below, F double prime. And then we should be able to look at our number line graph to see what's happening here. Number line graphs for concavity and increasing, decreasing. So we're going to propose to draw a function of f here, a graph of f. Okay, and we are increasing from infinity all the way to -2, and we are concave down over that interval. So we're going to get plus minus. So we're looking for the plus minus piece first. And where is that located? Well, it's this one right here. And we're going to be going all the way to -2. Okay? So we're going plus minus, which means we're concave down, but let's see if I can do it in a better place. We'll say concave down, but increasing. So I'm concave down, but increasing all the way here. Okay? Now what happens between -2 and 1? Well, what we have for between -2 and 1, we're going to decrease, but we are going to still be concave down. You see that? We have negative, negative, up the way to -1. And so to -1, we're going to be decreasing all the way to -1. And then between -1 and 0, what are we doing? Well, we are concave up, but we are still decreasing. So concave up, we're still decreasing. Let me write it over here. We're concave, we're still decreasing, but concave up. So that's going to be this piece over here. Okay, decreasing, concave up. So we're going down, but we are concave up all the way to 0. And what happens at 0? Well, from 0 on, we are plus plus. So we're going to be plus plus, which means we're going to be increasing and concave up. So that's what the graph of our function is going to look like. I mean, basically. And then what is another, what can we do for this equation? We have f prime of x, last thing we're going to do, find a possible equation, equals 18x squared plus 36x. Okay, f of x, or possible f of x, is going to be 18x cubed divided by 3 plus 36x squared divided by 2 plus c. And so we could say, I'll just say plus c, we don't know what it is. And then that's going to simplify to 6x cubed plus 18x squared. And we'll say c equals 0. If c equals 0, then we would have plus 0. So that's just a possible f of x. Okay, I hope that was helpful. Let's go to problem 4. I offered to look at that one as well. So we have a function of f prime of x. I said x. Well, really, we're in terms of a here. So I'm going to change the nomenclature. F prime of a, since a is a variable, we have 9. I'm going to put x. F prime of a equals 9 a squared minus 25. Now we can use a different factor using a difference of squares. So we have 0 is equal to, we're going to have 3a plus 5 times quantity 3a minus 5. So that's our factored form. So we're going to have 3a plus 5 is equal to 0, and 3a minus 5 is equal to 0. So our critical numbers, a equals negative 5/3, and also a is equal to 5/3. So we're quite symmetrical here. And then our analysis will be going something like this. We have our f prime of a, and then we have our f of a below here, and we put negative 5/3, and then 5/3 here, and then to the left of negative 5/3, say negative 2, we're going to have a negative times a negative. So we're going to be increasing. And then at 0, we're going to have a negative times a positive. So we'll be going down like this. And greater than 5/3, we're going to have a positive times positive. So we can say f of a is increasing on neg infinity to negative 5/3, and also from 5/3 to less than infinity. Why? Because f prime of a is greater than 0. Okay, f of a is decreasing on negative 5/3 to 5/3, because f prime of a is less than 0. Okay, now we have a relative max at a is equal to negative 5/3, because f prime changes from positive to negative. We have a relative min at x equals 5/3, because f prime changes from negative to positive. Okay, and I'm trying to remember if I did that for the last one here. You know something? I don't think I did the relative maximums and minimums here, did I? Well, I'm going to come and do that later. Just something I forgot. Okay, we're going to try to find the second derivative to find the, okay, so f double prime of A is going to be equal to 18A, right? So for this one, our critical, I'll just say so our critical number is A equals 0. And so what that looks like here in the number line below, let me get a little more horizontal looking number line if I could. That's a little better. So at 0, we have f double prime above and f below. And so we have negative to the left of 0 and positive to the right of 0. So that's what that is going to look like. And now coming up here, we will say we have f of A is concave up on 0 to infinity because f double prime of A is greater than 0. F of A is concave down on negative infinity to 0 because f double prime of A is less than 0. And we have a point of inflection at A equals 0 because f double prime of A changes from negative to positive. Okay, and then for a possible sketch of a graph, we have our critical numbers negative 5/3 and 5/3. We see that we are this circle business again, okay, with the circle here. Oops. Let me try that again. A little bit better looking circle. It's hard sometimes to draw this freehand. All right. Okay, it looks a little better. So we are increasing concave down, decreasing concave down, decreasing concave up, increasing concave up. Okay, to the left of negative 5/3, we're increasing concave down, so it's going to be a plus minus, right? So we're going to be increasing concave down, and then between negative 5/3 and 0, we are decreasing concave down, so that's going to be negative negative. So it's going to, our piece up to 0 is going to look like this. decreasing concave down, okay? And then between 0 and 5/3, we are all of a sudden concave up, and we are still decreasing, okay? So the point of inflection is going like this. So now we're concave up, still decreasing. And when we get to 5/3, after 5/3, we are plus plus, which is going to be this thing over here in the lower right. So we're going to look like this. So that's what our graph is going to look like. And finally, if f prime of a is equal to 9a squared minus 25, then we have f of a is possibly equal to 9a cubed divided by 3 minus 25a. So f of a is going to be equal to 3a cubed minus 25a. And we can make this c whatever we want. We say plus 2. And actually, based on the sketch of the graph, it looks like we might be minus 2, right? So I'm just going to put minus 2 just to better correspond with what this graph looks like here. So anyway, that's it. Let me go back to that other one where I neglected to do the relative. We have a relative max at x equals -2 because f prime of x changes from plus to minus, right? And we have a relative minimum at x equals 0 because f prime of x changes from negative to positive, period. Okay? So now I ask you also to treat this equation here as f prime of x, and for 6 and 7 as well. So for number 6, x squared minus 11x plus 18 is f prime of x. And finally, problem 7, 36x squared minus 49 equals f prime of x. I think this one here is going to be quite a bit like, 7 is going to be quite a bit like number 4 when it comes out. Anyway, good luck, and thanks for viewing.